in keeping our water issue seminars going since the start of that pandemic lockdown a couple of years ago. This has been a really great success story, I think. We used to have all of these in person, and now we're doing them via WebEx, as you know. And, we've had great success. So thanks for the continued tuning in to these seminars. It's been really good to keep it going. It's a real pleasure to introduce our speaker today. Um, Dr. Kenny Blumenfeld is a climate scientist who works for the Minnesota State Climatology Office, the Department of Natural Resources, where he provides the state's many clients, different agencies, communities, and citizens with up-to-date scientific information about Minnesota's changing and variable climate. I think we've all been really looking forward to his talk today. Hydroclimatic changes in Minnesota, observations, trends, and projections. Ken is going to talk about um, he's going to be breaking down the observed trends in the regional climate to its essential points, as he puts it in his abstract. And he's going to talk about distinguishing the region's long-term and significant climate trends from typical variability, something that I've always wondered about, and I think a lot of other people have as well. And he's going to describe how these two components of our climate can lead to unprecedented conditions. Ken, it is really an honor to have you with us. The floor, as it is yours. Take it away.
Very good. Thank you. Hi, everybody. Thanks for having me, and really good to be here. I was kind of stalking to see some of the names. Quite a few people I recognize, even some meteorologists in the house. So good, good. Anyway, thanks a lot. So I'm Kenny Blumenfeld, and I'm a climate scientist with the Department of Natural Resources in our state climatology office. And my job, I guess there's a lot of behind the scenes stuff that I do that's not particularly public, but I'd say what I do the most that I probably most people who work with me would associate me with doing is kind of being the state's climate science deconfuser. That's not a word, I just made it up, but there's a lot of information out there about the climate, and there's a lot of different sources of information, and there's a lot of variation in the way that people understand that information. And bringing it all home to Minnesota and making it make sense to Minnesota has been kind of my number one job since I got here in 2015. I love what I do. Like some of the other folks on the call, I grew up in Minnesota. I've always been fascinated by the weather. And so this is something that's afflicted me for my whole life, basically, ever since I think I was about 4, and I stopped wanting to be drive a garbage truck. Although I still think garbage trucks are awesome. But anyway, and from then on, it was weather, 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 and I feel really lucky to be able to talk to Minnesotans about their weather and what's going on with it. All right, so we'll get started. Whenever we talk about the climate and how the climate is changing, I always like to remind people that we're in Minnesota. I mean, we're a distinct geographical location, and that's actually true everywhere. Every place is different because it's got its own geography. But think about what this means. We are in Minnesota. We are basically halfway between the equator and the North Pole. We are equal distances from the Gulf of Mexico and the mountains to the west. We're also equal distances from either of those and the Arctic or Canadian tundra, and at least the cold prairies off to the north. So our climate has been shaped by the source regions for our weather. It's always been that way. You might think of Minnesota as having long and cold and snowy winters, maybe short, but sometimes hot and humid summers. And if you were to go a little bit deeper, you'd say, yeah, well, sometimes the winters aren't as long and cold and snowy as you'd expect them to be, and sometimes they are more so. Sometimes our summers feel pretty long and hot, and sometimes they seem like they almost didn't come. Sometimes they're stormy, sometimes we're in drought. But in general, what I just did was pretty much explain the gist of Minnesota's climate. And now just think about that. Now, what if you were to do the same thing for California? You couldn't use those same terms. There, maybe there are some passing similarities, but we really are distinct because of our geography. And, by the same token, so is California. So it shouldn't surprise us that if we have a different baseline climate, that maybe we're not all changing in the same way. And this is important because, a lot of people aren't climate scientists. They're not following climate stories, and they're not following um, maybe the breakthroughs in the science all that closely. And maybe they're getting information from the news. Maybe they're getting it from just kind of hearsay. Well, a lot of the news that comes out isn't specifically about Minnesota, right? A lot of times it's about oceans, it's about global averages, it's about coastal areas. And, very rarely is like a national news story actually about Minnesota. So people understandably don't necessarily have a good understanding of what's happening here. I like to remind folks that there's a difference between understanding the climate that's gotten us to where we are right now and trying to understand the climate of the future. It's two different branches of climate science. I'm pretty lucky in that I actually get to have my feet kind of on both sides. It's not common. Usually, there's so much work to be done just understanding past climate, historical weather observations, climate mesonet, or sensing networks that take real-time observations, everything that gives you a number or some kind of sense of the climate that tells you what's been happening with the weather or the climate. Uh, that's all based on observation. When you look into the future, you need a way of simulating all the complexities of the atmosphere, all the complexities of the atmosphere as some of its chemical composition undergoes changes, as it interacts with an equally complex biosphere or with the ocean. So there's a whole branch of climate science that's just based on building these sophisticated numerical models that help us understand the weather and the climate of the future. You can have an entire career doing one or the other. Not that many people do both. I'm lucky that I don't actually run climate models. That's real difficult business. But I work closely with people who do at the University of Minnesota, and I've been kind of studying climate models for a while now. And so, but most of what we do as climatologists is really understanding ongoing trends. So it's in that observations piece. Uh, like pointing out, Minnesota's climate is famous for its ups and downs. I mean, not just as we go from those typically long, cold winters to the shorter, but sometimes hot or even ferocious summers, but from one winter to the next, from one summer to the next, from, 2 weeks within a summer to another 2 week period within the summer, we can get really big changes. We are famous for our variations. And at the same time, we are experiencing what you may have heard of as trends, these kind of persistent ongoing changes in our climate. It doesn't mean that every year we're seeing, for example, more precipitation than the year before, or that every year we are warmer than the year before. It's not like we're getting hotter, 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 wetter, 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 and there's no looking back. We still have ups and downs, but there are ongoing changes in the behavior of our climate. So I point this out because when people argue about the climate, which is kind of a silly exercise, it'd be better if we just spent time understanding it. Um, they're often arguing about, assuming they're not arguing about policy, often the arguments are about, confusing variability and trends. Oh, well, how can our winters be warming if it was cold last week? Or how can, uh, or on the other side, doesn't this hot day prove that things are getting worse? And neither of those are particularly informed stances. And I just like to remind people, even as we get warmer and trend towards wetter conditions, we are going to have variations away from that. We're going to have cold periods. We're going to always have variability. baked into our climate, even as we observe persistent trends in the way our climate behaves. So here's an example of this, looking at Minnesota's annual average temperatures. You could probably, if you just understand how to read a graph, going from left to right, you've got older dates or older years, and on the right side, you've got newer years. We go right up through 2021. These are average temperatures around the state of Minnesota from a gridded data set, and I plotted them in Fahrenheit because that's what most folks in this country use, the imperial system. And you can see kind of the whole story is right there. You don't even need me to fit any statistics to this, right? The whole story is right there. You see that there's a general trend, and you can also see lots of ups and downs along the way. And so just to kind of do the most obvious thing, we could use a statistical regression trend line, for based on linear regression or the least squares linear regression. This is just the crudest way of finding a trend. It certainly doesn't speak for every year, but it's saying, well, on average, the state of Minnesota is warming at about 1/4 of a degree Fahrenheit per decade back to 1895. That doesn't necessarily tell you the whole story. It doesn't capture the ups and downs, right? So maybe you want to use something like a nine period or a 9-year moving average. Just another way of kind of capturing both the trend in there, where you can see that the line or that squiggle is definitely advancing higher and higher on average on the chart over time, but it's capturing some of its ups and downs too. And there are much more sophisticated and statistically rigorous ways of doing this. I'm just showing for simplicity the fact that we do have an ongoing trend in our temperatures as one example, and we still, even within that trend, have huge variations around the trend line. So you should continue to expect wide variations in our climate, even if and as, and I shouldn't say if, but even as we continue to see changes. And then lastly, the science changes just like other things. I mean, it doesn't do complete 180s or backflips, but it does, we do learn things all the time. And my job is to stay up to date on this. So, I wouldn't say like every week I'm having my mind blown by some revelation, but there's pretty good stuff that's pertinent to Minnesota that I learn, every year or so, maybe a couple times every year. And sometimes it's something that we discover from our own data analysis. So here is what we have observed with a little bit of information about what's projected to continue. So we've gotten wetter and warmer. Pretty big shift that we've observed, and that's projected to continue. The main thing, I mean, Minnesota is funny because we're a real water-centric state. I mean, everyone is. It always kind of comes down to your water. And so people are going to feel changes in, the hydroclimate more than maybe other changes that are ongoing. So I've been putting wetter kind of ahead of warmer on this statement because that's what people seem to care about a little bit more. We spent the 2010s, especially the late 2010s, incredibly wet, and we were dealing with way too much water. And now we've kind of got the opposite problem. We had nasty drought in 2021 and nasty drought again in 2022, and they're really part of the same dry regime. And it gets people talking. But on average, we've gotten wetter. And especially on average, we've gotten warmer. We've gotten much warmer. And this is a major shift that we've observed that's also projected to continue. So we won't just stop getting warm, but we would actually continue warming for decades, most likely. During the winter time, what we've observed is it's a shorter season on average, and kind of some odd changes in the behavior of the season that probably won't have a lot of time to get into, but we've on average seen fewer cold days with lesser extremes of cold. Um, we've also had more snowfall because there's just been, on average, more water vapor around. And so we've had heavier snows and more frequent heavy snows than would be historically typical. But because of the warming of winter, we've still had less snow cover. The cold extremes have plunged pretty quickly. And what I mean by that is the frequency of days where it's just, -50 in northern Minnesota or maybe -30 in southern Minnesota. These days have really become less frequent. They still happen, but they are becoming less common. They don't happen as frequently as they used to, and when we get that cold, it's not to the same extent. This is all across Minnesota, all across the region. It's actually one of the strongest, if not the strongest, global trend. It's just that, it's subtle. People don't notice because, think about going from a day that, if we used to hit -30 in southern Minnesota, and now instead we hit -24 or -26. It's still really, really cold, and most people can't tell the difference between it. And you still could get injured. And so it's a subtle but important change, because some of the thresholds that we don't meet anymore do have impacts on our natural resources, like our forests and what grows here, uh, because there are sort of lockout thresholds that we used to hit that prevent certain things from flourishing. And when we don't hit them, now you have new invasive pests, or you have a takeover, a change in the forest composition and things like that. In the summertime, so far we've observed fewer cool nights. That's kind of been our big change. Minnesota has not yet gotten hotter, but it has gotten warmer during the summer, and it's mostly been through a loss of our really cool nights, again becoming less frequent and not as cool as they used to be. And those are turning more into kind of mild or maybe warm nights. And of course, during summer, we've had, on average, it's not every year, but on average, we've seen more frequent and heavier downpours, leading to some, in some cases, unprecedented flooding conditions in some areas. So we've seen more of these larger and big events, and that's also kind of like that's a slam dunk, pretty well guaranteed to continue, just based on the physics of how all of this works. So global temperatures increase, they automatically will evaporate water off of the oceans at a higher rate. That puts more water into the atmosphere, where it's stored as vapor. You might call that humidity. Humidity is, in a very basic sense, the fuel for precipitating weather systems. So if you have more water vapor around, or available, and then occasionally you're going to tap into a larger pool of it with a weather system, and it's going to squeeze out more precipitation. Um, I like to tell people, because there's a lot of interesting use of adjectives in Minnesota. I mean, not just here, but everywhere when you talk about this stuff. And a lot of people are convinced that everything's getting worse. And Minnesota, we have a lot of challenges. I would say that the state has been generally behind. Communities in the state have generally been behind on the climate that we kind of already had. And so scrambling to keep up with increases in precipitation and rainfall has been tough. It's cost some communities money as they've had to rebuild roads and culverts and whatnot. And then also, some of the changes in the winter have also been hard for the recreational industry, or for forestry, or even agriculture to keep up with. But honestly, when you look at sort of the whole picture of what's kind of the normal weather for Minnesota, and you think of all the storms and the blizzards, and not everything is getting, quote, worse here. Heat extremes, for example, have not intensified yet. This is lucky. They've started intensifying in other parts of the country, other parts of the world, but so far in Minnesota, only the far northern areas of the state have actually seen increases in the frequency of heat waves, or maybe in the severity of those heat waves. And it's been a pretty subtle change. It hasn't been like a spike. We haven't had that yet. But when we look around, we see this is happening almost everywhere else. It's kind of a matter of time. As the whole system warms, there's just going to be more warm and hot air around. It's going to take less energy to go from the higher temperatures that we're starting with up to 90, 95 degrees. So we know it's coming, but we haven't experienced it yet. So we kind of have this sweet spot where we can react to the things that have been changing, maybe prepare for the things that are going to change. But right now, we don't yet have any indication that these heat extremes are getting out of control here in Minnesota. I'm going to show you data for all of this, so it's not just me talking with words on the screen. Drought, as bad as this year feels in the Twin Cities, and as bad as the last 2021 was throughout much of northern and northwestern Minnesota. Really, there wasn't anything unusual about so far. If this goes on for 8 years and becomes kind of a little mega drought or a big mega drought, well, then we'll have to reanalyze this. But right now, drought as is, if you measure its longevity, its frequency, its severity, or the amount of area it takes up. None of those metrics are right now outside of historical ranges. In fact, they're well inside historical ranges. We would characterize last year's drought episode in northern Minnesota as, the highest level of drought, but among the drought conditions that meet that highest level, it's kind of on the lower end of historical drought conditions. This year's drought so far in the Twin Cities, it's been bad, but we've actually had much, much worse than this. So there's no indication that as our climate has changed, that as we've gotten warmer, that all of our, that our heat extremes or our drought conditions have taken off with it. However, just like those heat extremes, Minnesota goes up and down all the time. And as we start getting into hotter summers in the future, it's pretty likely that those are going to be at least occasionally accompanying really dry years. And when that happens, then we're going to have these, hotter, dry spells that are going to evaporate more water and potentially lead to more severe drought conditions. So, not something we've observed yet, but possible, if not, maybe more likely than possible in the future. And then, severe convective storms, tornadoes, large hail, damaging thunderstorm winds. We have more stuff, and we know that stuff gets hit more now, but there isn't any evidence from the data that the worst of these storms are becoming more frequent or worse. One change that I would definitely concede is underway in Minnesota, which is taken us to new places, is we are seeing the severe weather season expanding in ways that we just had never observed before. So last year, for example, we had October tornadoes on the Canadian border, which we'd never observed them that far north that late in the season. And then 2 months later, we had an outbreak of severe thunderstorms and tornadoes in southeastern Minnesota that kind of demolished our records for tornadoes that late in the season. I mean, it was like almost a full month later than any tornado we'd ever observed in Minnesota, and we had over 20 of them. So so even though we're not actually observing more of the really damaging tornadoes or straight line wind or hail events, we are seeing an expansion of the season of them, and the future is a little uncertain with those, where there's kind of a mixed consensus or no consensus on what's going to happen to the future of severe convective storms, but there's some indication that, we could see at least more big outbreaks, even if it means fewer days with severe weather. All right, so now let's start looking at what all this really means. So here's precipitation. Hopefully you can find Minnesota on the map right in the upper middle part. We're that tall state that looked like a tall rectangle with a bite taken out of the right side. And this is average, these are 30-year averages taken back to the beginning of the 20th century. And these are called normals. You've probably heard the term, but what we're actually looking at here are comparing each normal period to the 20th century average. And so if you see those sort of brown or drier looking colors, those would be periods that were dry, and the dark greens and what, I don't know, aquamarine or whatever color that is, would be wet conditions. And what you see for Minnesota is that we had the drought of the Dust Bowl really, really affecting the statistics through, basically the first 3 maps, maybe even 4 maps. I mean, it was a long drought. The Dust Bowl was in the 30s, but the drought actually was 23 years long. And so it was, or 23 years that were below what we currently think of as normal precipitation in the state. So that has a big influence on the record. But then by the middle of the century, we kind of stabilized and went back to sort of normal conditions. We went back to where we had been before the drought. And then the last 3 normals periods, we just went wet, wetter, wettest. so that, basically the 1991 through 2020 period in our whole region was the wettest on record. And the 2010s were Minnesota's wettest decade. Uh, so when we look at our historical network that has 100-year stations, and I'm probably going to need to change the way I analyze this because these are based on human observers, and we keep losing human observers, and we really need human observers. They're the most important type of climate data, still more important than having, lots of automated weather stations. But when we look at the stations that have 100 years of record, we and just hold that network of long-term stations steady, we can go back in time and see, okay, well, for those 38 stations, what's the largest daily rainfall each year? So what's kind of like it's not really the heaviest rainfall in the state, but it's the heaviest rainfall in the state for stations that have 100 years of record for each year. And what you see, your eyes will kind of tell you the story. I mean, it's certainly not safe or fair to say that every year we're seeing bigger and bigger rainfall events. That would be incorrect. If you look at the sort of the bottom of that distribution, kind of follow the dots that are around and above that 3-inch line, you kind of see that, all right, on average, typical heaviest rainfall in the state is probably a little bigger than it used to be. But then if you look at the top where it really fans out, what you're seeing is that beginning in the middle of the 20th century, and then with increasing frequency and at increasing magnitude since then, we're just seeing rains that we never used to see before. It's factual. I mean, it's not happening again. It's not everywhere. Not everybody has been dunked by, a gigantic cataclysmic 10-inch rain, but these have become more common, and they have, started hitting areas that had really no preparation for them. What we call mega rains. These are it's an arbitrary term. If you look on that map on the right, it's a precipitation contour map. And if you look for that 6-inch, kind of that pale blue area, we're looking for that area to be at least 1,000 square miles, which is about the size of a typical, average Minnesota county. And that's the definition of a mega rain. So 6 inches of rain falling over at least 1,000 square miles. This one here was actually about 2,000 square miles. It was huge. It went into Wisconsin with actually even more ferocity than it had in Minnesota. There's the outline of it. You can see radar loop. There were actually tornadoes in Stearns County and Meeker County that same day. But this was a big event, caused a lot of problems during a year that had a lot of huge rainfall events. And these types of events have become more common. They're still rare. Most years, you're not going to get hit by one unless you're really unlucky. But they have become more common. Their frequency has increased by a factor of about 2.5 since the latter part of the 20th century. So fairly sharp ongoing changes underway. This is one example of what can happen with these in Duluth. This is a picture from NPR down by Brewery Creek. And then after, and the point isn't to say that these are happening everywhere all the time and they're coming to your town this year, but they have become more common. It's one of the changes we're observing in Minnesota for sure. And then when we look ahead, we look at the projections, and this is, just one set of projections. There's a lot. On average, they show pretty much the same thing, that we're going to get more precipitation. We're going to keep getting wetter. So the way that those maps had us getting greener, more dark greens as you got towards the last 30-year normal period. We would expect, there's going to be, certainly this drought is going to have an influence on our precipitation climatology, but if the next normal period doesn't get wetter than the current normal period, then I would expect the one after that would. A general trend towards more precipitation is expected because there's more water in the atmosphere, and we actually have a pretty good relationship with a source of water at the Gulf of Mexico. So whenever the winds blow from the south, we can get that summertime humidity or even wintertime humidity going. The same models indicate that our region is also going to see more heavy and extreme precipitation. The kind of storms that, they might not wipe out your town, but they drop 2 inches, 2.5 inches of rain. Maybe those happen 1 to 2 times a year on average now. They would be happening more like 2 to 3 times a year on average in the future. That sounds like a really minor change, but it's actually like a 50 to 100% increase in frequency. And remember, with the normal ups and downs built into our climate, then you have to assume, well, some years we probably won't have any, right? It's going to be dry. You're not going to have any 2.5 inch rainfalls. But other years where it just doesn't stop, kind of like we had in much of the 2010s, maybe you'll have 7 or 8 or 10 of those types of rainfall events. And that's going to be really hard to keep up with in certain towns. Interestingly to me, while we've been getting more precipitation, we've been also getting more snow, and especially more heavy snow. And we could do this graph all over Minnesota. This one shows, the bars show average seasonal snowfall. And what you see is the 2010s in most places in Minnesota, they were not necessarily the snowiest decade on record, but they were up there. And in some places, like out in western Minnesota, southwest Minnesota, it was the snowiest decade on record. But then the dots with the lines, what they show are the number of days with heavy snow. That's 4 inches or more falling in an observation day. And that actually across the state reached all-time highs in the 2010s. I'll get to why that's kind of interesting in a moment here. Well, let's begin. So same thing, but for temperature. The whole country's gotten a lot warmer. I mean, that's one area where we all share the same general direction. Everyone's getting warmer. But you could see that our region was kind of first to the party. We were, especially if you look not at the very last image, but the second to last one there from 81 through 2010, we arrived at really rapid warming faster than much of the rest of the country. And then you see in the most recent normals period, a lot of the rest of the country has started to catch up and reach that level of more intensive warming. But yeah, lots of warming is throughout the U.S. and you see a little island where it's not getting as warm in the central and southern U.S. And that's actually a topic of curiosity and study. So when you look at Minnesota in particular, how have we warmed? What is our total warming since our continuous records begin? And basically in southern Minnesota, you see we have positive, if you look on the left, the whole state is warming. Northern Minnesota is warming faster. You'll see that in every season. And this pattern continues off into Canada. It's actually, the simple explanation is that this is something that all climates that have greenhouse effects would observe. So it's basically that the greenhouse effect is stronger at higher latitudes. This has to do with what the greenhouse gases are actually doing. They're absorbing something called long wave radiation, which is the heat that comes off of the earth after it's heated by the sun during the day. So it's essentially the heat that's lost during night and during the winter time. And at high latitudes, we have longer nights generally and longer winters. And so this is where we tend to have a stronger greenhouse effect. And so as we've changed the climate through enhancing greenhouse gases, one of the changes that we're seeing across the world is higher latitudes tending to warm faster than low latitudes. And we certainly see it here in Minnesota. But the fastest warming time of year is our winter nights. So the middle map shows that basically in northern Minnesota, a typical winter night. Now, this isn't going to be true all the time, right? I mean, we're not talking about everywhere, every time, every night, every year. But on average, if you took a handful or a representative sample of winter nights from northern Minnesota from the most recent 20 years or so, and then compared them to the first 20 or so years of the record, or some earlier part of the record, you'd see much higher temperatures on average in the recent period. A typical winter night in northern Minnesota is now about 7.5 degrees warmer than it was 100 years ago or so. We're not observing the same thing on the right map there for summertime days. You do see northern Minnesota's summertime high temperatures are increasing, but not at the same rate, obviously, as wintertime nights. And you see in southern Minnesota, there's actually been a downward trend. It's not statistically significant, but our summertime days certainly are not getting hotter in southern Minnesota. And it's hard to make the claim that summer days are getting hotter in Minnesota at all. I mean, we had some hot conditions in 2021 for sure, but that was not part of a trend. And we'll look at that too. What is part of a trend is what's happening to our cold extremes. So here we're out in Milan in western Minnesota, and temperatures, this is the lowest temperature of the year, and you could just see progressively getting warmer. So one way to interpret this, I don't know if you can see my cursor here, but I'm pointing at sort of towards the right. There's a nice low temperature of -33 from 2019 out in Milan. And that was really cold. They hadn't been that cold in a while. But then if you look left on the graph, you can actually see how common -33 used to be. You could look even lower and see values that used to occur with some regularity that don't occur at all anymore. And here we're in a rural setting that does not have an urban heat island. And this is just something we're seeing across the entire region. What we used to think of as cold doesn't really happen very much, if at all, anymore. And what we now think of as cold used to be pretty common. So out in Milan, the blues, the bar graph shows that Milan in the 2010s had its snowiest decade on record. It was a great time for snow for them. But look at that orange line. They also, during the same decade, had more nights that remained entirely above freezing between November and March than any other period on record, and kind of by a lot. I mean, it's really taken off. So this is another thing that we're seeing is more days that are thawing during the winter time. So these are both true. We had more snow, or at least historically high snow during the 2010s, and we also had record-setting thaws during the same period. More thaws during wintertime than we'd ever observed across Minnesota, and that's a trend that's, certainly being upheld by the last couple winters. As much as people want to say, "Oh yeah, last winter it was brutal," we did have like a 3-week period that was pretty tough. And in 2021, it was more like a 5-week period. And our winter, if this last winter did linger kind of long into April, but we had all kinds of thaws. We had a lot of winter rain events. That's another thing that we're seeing more of. They're still uncommon, but in the Twin Cities, we've seen this steady increase in the average number of days with winter rain. Take that last bar graph. Obviously, we have not gone all the way through the 2020s yet, so you got to be careful with that. I should have an asterisk there, but there has been this increase, and it's true across the state. It's not just the Twin Cities. We've seen it in Duluth. So days between, say, that would be December and February, where you have precipitation falling and it's not snow, and or the temperature that day remains entirely above freezing, those kinds of days are more common. And so you end up, even if you're getting more snow, you end up kind of with a strange snowpack that maybe is kind of low quality in terms of its texture. Or in the case of Duluth, they just melt a lot more snow than they used to. So in Duluth, for example, we see those light bars show an average decrease in the amount of snow on the ground between November and March. And then each of the lines shows that either 6-inch snow depth has gotten less common, or 1-foot snow depth has gotten less common by 35%, or the days with no snow on the ground between November and March has increased by over 60%. This is, again, something we're observing, maybe not with the exact same statistics, but we're observing this across Minnesota. We still get winter. We still get wonderful snows. we still get brutally cold conditions, but we're also having a harder time keeping the snow on the ground, and it's changing the fundamental timing of our hydroclimate. Uh, Actually, Carl's got a much better version of this that I've been putting in most of my presentations, but depending on what period you're looking at, um, Minnesota's lost about 2 weeks of ice cover on a typical Minnesota lake. There's variation in there. You can go and look at the data set. PCA's has this really wonderful tool that allows you to examine the trends in different parts of the state and for different lakes. But maybe someone can throw that in the chat if you're not aware of it. It's an awesome tool. We use it all the time. This previous analysis was done by the Department of Natural Resources before that tool was built, but it's the same thing. We're losing on average, 4 or 5 days a decade of annual ice cover on Minnesota lakes, and in recent decades, and going back to 1970 or so, the total loss has been about 2 weeks. So a typical ice cover season just has less ice on Minnesota lakes. And this is matched by other things we're observing. The growing season is expanding and the frost season is shortening. So here we're back at Milan. You can see the ups and downs, but the first freeze of fall is tending to come up to a week later. And the last freeze of spring is coming up to 2 weeks earlier. I mean, these are pretty important trends. We just don't spend as much of the winter time entirely below freezing, and we're seeing an encroachment of the period where things can be growing because there's no freezing conditions. Uh, this is interesting. We don't know how this one fits in. We've had more winter. I mean, actually, this was just our winter gusts. Last year was kind of off the charts. We had more gusty days in the Twin Cities than any other year on record. We know that the same is true. It's holding true for the year in general. It's just been a gustier year. The thing we also know is that there were some important instrumentation changes at the airport that make the instruments, they're more sensitive. And so they're reading the wind more accurately, but the old equipment probably wasn't picking up some of those gusts that were actually occurring. So we don't know to what extent what this graph shows is just instrumentation, because we've heard from so many people. I know it's anecdotal, but we've heard from farmers and foresters and people with 40-year careers that this is the windiest I've ever seen it, and they're not looking at data. They're just basing that on their senses. So it's something we're looking at. We don't have a good explanation for why it would be windier in terms of how the climate might be causing that. We just know that it's happening. And as I mentioned, our summertime maximum temperatures, and I could actually include 2022 in this now, and I can just tell you that it's not as high as what we had in 2021. So it goes back down closer to kind of the upper middle part of the graph. So the average high temperature during summer does not show a trend like the way that we've seen with, the coldest days of the year or the winter nights in general. We just don't really see anything like that. There's no indication that what we observed in 2021 is part of a trend where we've had lots of days, lots of years like that, or that that we're on our way outside of the historical ranges for summertime high temperatures in Minnesota. And when we go back to Milan and look at the hottest days of the year, we don't really see anything. This goes, I also took this one right through 2022. It's just not updated here, but there isn't anything suggesting that we are getting hotter. The hottest days of the year are not becoming more numerous or hotter by any measure throughout the majority of Minnesota. Again, there's a slight exception in northern parts of the state where they have had more 90-degree days than was historically typical, but most of Minnesota is not observing that. But the caveat here is that even the most optimistic climate models show that we are going to get much hotter. And this makes perfect sense because there's more heat in the system. As global temperatures rise, you're going to have fewer cold air reservoirs and more warm and hot air reservoirs, and it's going to take less energy. If you're starting spring or summer at a higher baseline for temperatures, it's just going to take less energy to get you to 90 or 95 degrees because it's going to be a smaller amount of change required. So most models, and this is a very optimistic one that actually shows that people know how to work together, and countries are say they're going to cut emissions and they actually do, and everyone's holding hands and everything's working out really well. And even in that rosy model, we get absolutely pummeled by hot weather by the middle of this century. Um, the way to interpret this would be a typical place in Minnesota sees a 2 to 3 fold increase in the number of 90-degree days. So you used to get 10, now you get 25. You used to average 5. Well, it'll be more like 12. So 90-degree days, that's a driver of our discomfort. It's a driver of our water use, and certainly would contribute to drought conditions worsening. I do have a lot more information that I could share with you, but I'm going to hold off on some of this. I'm just going to do, for you severe weather buffs, I'm just going to put in one interesting statistic about our um, tornadoes. Ooh, our tornadoes do appear to be increasing. I want you all to pay close attention. Um, the frequency of tornadoes on an average annual basis does appear to be increasing. And but if we look at this by the ones that are kind of on the bottom of the ranking scale, we see it looks almost the same. Now let's look at the ones that do consequential damage. They're in the EF2 to EF5 range. And you can see there is no indication that these tornadoes are becoming more common in Minnesota. All I could vouch for here is some kind of, normal ups and downs that move with the normal variations in our sort of decadal scale climate. We could look at this more closely, but the point is there's really no indication that the tornadoes of consequence are getting more common. And what's actually happened is, we have more spotters, we have better radars, we have better meteorologists, we have better verifications. And so the tornadoes that we used to miss, the kind of little ones, we don't miss them anymore, or not nearly as much. And so that's driving up the statistics. And this is, by the way, very well known in the severe weather research community. I'm not just like having fun with numbers here. I mean, this is something that climatologists and meteorologists across the country have known about and discussed and tried to figure out how to, like, what it means for a long time. Um, and the same is true when we look at, the hail or wind events of true consequence. There's no upward trend over this. It's a shorter period that I'm looking at here. It's a 15-year period, but there's no indication that things are kind of going, off the charts. Just normal ups and downs that you would expect with our climate. So that's kind of the good news about something that's not changing and where we don't have a lot of information or a lot of consensus about where it's going in the future. You should expect tornadoes and high winds and hail and all of that to be part of Minnesota's climate, but not necessarily to be worse, not necessarily to be worse in the future. But what we can say is, we've gotten wetter and we've gotten warmer, and both of those trends are expected to continue. However, expect the ups and the downs along the way. Expect the drought will be a fixture of our climate. And so when we have those years where we're kind of down on precipitation, but up on temperature, way up on temperature, those could be years of really nasty drought conditions. And that hot weather hasn't yet worsened, but let's not be fooled by that. We've got time to prepare, and we should probably be doing that now. All right, thanks everybody. I did see a question come up. I wasn't able to read it because I was yapping, but thanks everybody. I'll take questions if looks like we have a few minutes. Thank you.
Kenny, thanks so much for the talk. How fascinating it is to see, what you present in terms of statistics and numbers versus perception. I think that's always just really interesting. It always seems to kind of catch us, all of us, um, making perceptions when they may or may not be true. Brooke, do you want to jump in and catch questions from the chat.
Yeah, it looks like we do have a question in there from Fox about the rain and snow. I'm not, are you seeing the questions in the chat now, Kenny?
Oh yeah, okay. Let's see. Okay. Maybe I'm jumping the gun a bit ahead here. Maybe I'm jumping a bit ahead here, but there are trends, expectations about rain and snow. How about ice and ice accumulation? Aha. Very good question. The ice situation is another one of these kind of confusing and nuanced ones because think about, so if we are, it kind of depends on the type of ice. We don't have any trend towards more ice storms in Minnesota. We know that just based on the historical record, but an ice storm, if you think of it as those days where at least a tenth of an inch or a quarter of an inch, kind of depends on the threshold you use, of ice accumulates somewhere. But that's, freezing rain and is a very specific type of ice. But on the other hand, we have seen increases in surface ice that results from just, wet snow falling that then freezes into a sheet. We've had this a lot. Or where, how many days, uh, we don't have a way of counting it, but those kind of crunchy days where it slushed the night before and then the temperature dropped 35 degrees as the cold front came through, and you end up with this kind of crunchy, chunky surface ice that forms as a result, especially once the cars start driving. We know that we've melted more fallen snow. And then because of the sort of typical behavior of our winter, that we then often will refreeze that melted fallen snow, and that has to become ice. So we know that there have been increases in the coverage of surface ice. And probably those are going to continue as we melt snow that falls, or as, you have a warm rain falling in the winter, but then that's almost always followed by a cold front, which will drop the temperatures below freezing. So it's a really good question. Ice storms in particular don't show any signs of increasing here in Minnesota, but conditions that lead to ice accumulation, even if it's not related directly to precipitation at all, but more to the melting of snow or, or a delayed drop in temperature, those seem to be increasing ice coverage. So we've got pretty strong evidence of the latter, but no real evidence of like ice fall accumulation increasing. I hope that helps. It's a really good question.
Yeah, thanks, Kenny. And I will say, just from my vast experience working with winter maintenance professionals, they are seeing an increase in what they would call events. So for a snowfall doesn't usually trigger a de-icing event, but refreeze events and these temperature changes as we get kind of mixed precipitation, that's definitely something they're seeing an increase. So that is kind of, maybe that is measured, like maybe we, could work with the winter maintenance, organizations across the state to collect a little data. I think MnDOT was actually looking a little bit into some climate change impacts on the winter maintenance industry, but there's definitely been an increase in the number of events that are requiring some kind of chemicals to manage that.
Yeah,
phase, so.
and I worked with the Public Works Safety Group who had reported a record number of staff injuries from falling in parking lots during the late 2010s. And that's, an area where, so people are going out to their trucks or their cars and they fall because there've been, just more icy conditions. And there were years where, again, anecdotally, we noted that lots of climatologists seemed to fall in a couple of the winters in recent memory, where it was like, almost like everyone knew someone who went down pretty good. So I just want to get to a couple of these other questions. Lee asked about humidity. The trends in humidity are actually very similar to what we see with temperatures. So by and large, the really dry conditions just don't tend to be as dry as they used to be. And this seems to be because there's more moisture available in the whole system. And, I could show you a graph too that shows like our drought years. Even though we're in a really bad drought right now, we also see that our drought years tend to have more precipitation than drought years of the past. And we're seeing the same thing with humidity in general, that when it's dry, it's just, there's a little bit more moisture in the air than when it used to be dry. And so, so there's been an overall increase in humidity. There is a slight increase in the sort of extreme humidity, which I think is what most people think of when they think of humidity. And when we look at what we call humidity-driven extreme heat events, so the ones where maybe the temperature isn't 105 degrees, maybe the temperature is only 95 degrees, but the dew point is up in the upper 70s or maybe even the low 80s. And so it feels like it's 110 or 115 or maybe even higher. Uh, those are still extremely rare, but they have become more common in recent decades. They have become, I'd say slightly more common. It's a subtle increase, but I would imagine that that's going to continue. And then Carl asked about the effect of albedo. Um, Albedo is when that's the reflectivity of the snow, and it's so when you have snow, sunlight bounces off of it, and therefore the sunlight can't be absorbed by the earth, and so you don't get as warm as you would. It's kind of a cruel trick, right? So when you see there's been a big snowstorm and you come out of a building and everything's bright and glary, what you're really seeing is heat escaping from your life. Um, and and that is one of the drivers of wintertime cold. And when you start to when you erode the snowpack or dirty it up too much, then you change the ability of the snow to reflect that sunlight away, and that can make surfaces warmer. It's a secondary effect here, but we know that when we lose the snow cover, then 2 days with the same meteorological conditions can have a temperature difference of 20 degrees. So a really cold day in the wintertime with no snow on the ground might be 20 degrees warmer than the same day under the same atmospheric conditions with a healthy snowpack, a healthy fresh snowpack. So it does make a difference, and it would feed back into some of the climate warming that we've observed. We just know that the first mechanism is that it just also, when there is snow on the ground, we're still not as cold as we used to be. Really good question. I don't know. There's still some folks on the call, so should we keep going with questions? I can stick around for a few more minutes, so I'm
Yeah,
happy to
there's
do.
there's no one's going to kick us off here.
Okay.
Maybe we can take a few more.
All right. Is the next question from my buddy Dan? Looks like many have noted anecdotally, of course, are springs being less spring-like in recent years. Let's see, climate change trend or more related to La Nina, El Nino, or other short-term um, atmospheric flow events, or is it just an annoying fluke? I think so. What Dan's referring to, and I think I got this right, is there's been a really strange tendency in recent, especially the last 1 to 2 decades, for winter to last longer. We had it happen last year. We had it happen in 2019, 18. You could possibly make the case it happened in 2020. It definitely happened in 2013, where and it's this condition where you maybe don't even have much of a winter until you get to February, and then February turns it on, and then you have snow on the ground lasting into or through March, and you have winter type conditions lasting into April. And this has had the tendency to pull temperatures down a little bit. It's slowed down the warming that we've observed in that season for sure. It's actually showed up when we look at our normal temperatures across the state for some of the spring months, like we actually see a signal because there wasn't as much warming during those months as in other times of the year. What we don't know is, why is this happening? There had a lot of those years that we mentioned did have, they were like La Nina type years. And La Nina is a cooling of the Pacific Ocean at the equator or near and at the equator. And that can be related to intensified winter conditions here. But the thing is looked at the behavior of La Nina winters here, sort of before, like historically versus recently, and they've changed. Like the way that our winter responds to La Nina is different now from how it used to be. And one of the differences might be these kind of later breaking winters that, deliver much snowier or colder February and then possibly linger into April. We don't know. I would be dishonest if I said I understand the science of this. I think that, some of it is probably related to the changes in the flow as they interface with increased global temperatures, which also change ocean temperatures and ocean circulation patterns. And that interacts with this anomaly that we call La Nina. That would be one guess, but I don't know the extent to which this is here to stay versus kind of it's going to be, a 20-year blip that we see in the record and eventually gets kind of fuzzed out as other changes occur. It's a really good question. I think we're all kind of hard pressed to find good answers, solid answers for it. Any question? Oh, and then Matt, is there a change in the temporal aspect of variability? Do we see shorter spells of the mega rains followed by more flash drought? Okay, what is the physical mechanism of that? Okay, yeah. So let's start with the changes in the variability. I think yes, what's been sort of predicted and we've started to see in some of our observed data is that even in our wet years, we've just had precipitation has become more episodic. But we have to be careful with this. So 2018, we set two all-time records for precipitation. First, Caledonia broke the long-time record at that had been set at Wasika, and then Harmony broke the Caledonia record in the same year. And it was and in southern Minnesota, it was a very wet year. But when we looked at the pacing of precipitation, it was episodic. There were in the fall there was a multi-day run where we couldn't get out of a wet pattern. But mostly what communities were observing was an inch to an inch and a half of rain, followed maybe by within a couple days by another decent rain, and then a 1 to 2 week break where it didn't rain at all, and then more episodic precipitation, and then another longer break. And that definitely is a change from what we had observed historically, which is that you could actually bank on rain every 3 or 4 days, and in a wet pattern, maybe even more than that. And then when we started getting into wet patterns in the 2010s, what we would find is the spigot would just be on all the way for 3 weeks straight, and then it would shut off for another 3 weeks. And so there's been some change in the pacing, and some of this was anticipated by the scientific literature and by the models. And some of it is probably too nuanced and too fine in detail for us to understand why. In terms of the mechanism behind it, I mean, the overarching theory that was proposed about a decade ago still actually holds up. It's been modified a little bit, but there is, and this is going to be maybe too deep for some of the people listening, but I'm going to try my best to make it general. The jet stream or the steering winds that you see on the Weather Channel or on whatever your forecasting resource is, that you've probably heard about it. These are actually really important winds for moving weather systems around the world, and they're more they're more complex than what you see. What we used to see on the Weather Channel was like this kind of slinky thing that would move, it would undulate across North America, and there can be multiple streams of wind, but they are driven by the atmospheric dynamics of the northern hemisphere. So in our hemisphere, it's really driven by the changes in the hemispheric temperature gradient. So as you go from the really warm equator to the generally colder poles, that that gradient determines the intensity to an extent, the intensity and the shape of the jet stream. And so to Matt's question, well, why would the pacing of weather systems be changing? One thing we know is we've diminished the global temperature gradient, and that would tend to make the jet stream, and this is a little counterintuitive for those of you who aren't meteorologists, that makes the jet stream weaker, which just means it waves more, it buckles more. And when it buckles more, it actually can produce stronger weather systems, but they move more slowly. And so they get stuck in place. So you get stuck, it's easier to get stuck under what we call a ridge, which tends to be kind of dry or benign weather, and in the summertime can be very hot weather, or stuck in some part of a trough, which in our field that corresponds to generally stormy or inclement weather. And so we tend to see these longer episodes where you're in one or the other. And there seems to be a relationship between that behavior of the jet stream or the steering winds and the overall changes that have been observed in the hemispheric temperature gradient. So that's what I got. Is there anything else before? Wow, lots of questions. Great. I appreciate all these questions. Okay, so I'm going to just look at these. I see one from Cameron, one from Brooke, and then I'll cut it there. Okay, trends in less extreme cold, but not yet for heat extremes. Will the continuing cold trend potential feed a hotter trend as time goes on? Okay, so possibly. The question is, well, if we keep getting warmer winters, is that eventually going to feed our hotter summers? And I'd say that you can't really decouple the two. So in that way, it's correct. Yes. Because as winters become less cold, that means that you're going to be able to start spring warmer, essentially. And once you can start spring warmer, it takes less actual energy to, like, so just as an example, going from 65 to 95 degrees requires more energy to produce that change than going from 74 to 95 degrees. And so if you start spring and summer at a higher baseline temperature, then you don't the same amount you can have the same amount of sun which you've always had and the same amount of southerly winds, and you're eventually going to just go farther with it. You're going to get to higher temperatures, or you're going to get to those high temperature thresholds more frequently, or you're going to have, if it's humidity driven, you're going to have more of those kind of really oppressively humid days. So in that way they are connected. But there's also some mechanisms that are going on that are kind of distinct to the two seasons. And one has to do with the presence or absence of snow and ice cover during the winter time, which is what ultimately determines kind of how cold winter can be. And that's especially globally and hemispherically. And then changes in things like vegetation and vegetation cover during the summertime, which also alters how much of the sunlight that's reaching the earth can actually be observed. And then what we learned in 2021, and I think we're going to keep learning, is that there are other effects that might surprise us. So we were really primed to have an incredibly hot summer with some catastrophic heat here in 2021, but we had so much smoke and dust in the air, it was suppressing the temperatures by up to 10 degrees on a few days, on several days. And that is something that I think is hard for the climate models to account for. And that's an effect that actually could drive down summertime temperatures in a way that maybe we're not anticipating, and probably in a way that's also not good, but is distinct from anything that's happening for the most part during winter time. And then the last question from Brooke was
Actually, you can
oh,
just skip mine. Mine
yeah,
was just a
a
comment
comment.
when you were
Got it.
talking about humidity, and that humidity is actually really important for knowing and understanding
Oh,
for maintaining our roads in the winter. So,
okay. Well,
um,
John asked
yeah.
about how do we know that we're not part of a larger cycle, since we only have 130 years of data. And there are going to be climatic fluctuations on the scale of multi-decades that, as we get more and more data, we'll be able to see, oh, okay, this was sort of a naturally occurring up and a naturally occurring down. It's just that we know, I mean, here's what we know about climate. that if you were to hold the Earth's climate and composition steady and you didn't change anything, then we know the main thing forcing changes in our climate is the amount of sunlight reaching the Earth, or the intensity of sunlight reaching the Earth, which is governed by long, like astronomical scale changes in the orbital and axial components of the Earth. So like our tilt on our axis changes very, very, very gradually on the scales of tens of thousands to hundreds of thousands of years. And so does the actual orbital path that we take around the sun, that it goes through these periodic switches. And we know historically that those result in climatic changes. So those Milankovitch cycles, they're called, are always going to be there no matter what we do to our atmosphere, and will have an influence on data that comes out. But those, we're kind of coming out of the longest Milankovitch cycles, the most recent ones, and they're not currently having an effect on our climate. But the other things that would affect our climate would be volcanic activity or catastrophic events. And with respect to sun, we know from using all of the equipment that's been deployed by NASA and other solar observing agencies that there's nothing with respect to incoming sunlight or solar radiation that has that would be driving our climate to the kinds of warming extents that we've been observing in the last, especially in the last 50 years. In fact, if you look at the behavior of not just the sun, but also sunspots, we would really be projected to be on a slight cooling cycle. And so when you subtract out that effect, then you go, okay, well, why are we warming then? And then you can start, understanding that, oh, well, it's, we've increased the concentration of greenhouse gases, which actually trap heat. And so trapping heat means you're going to raise the temperature. So I mean, we're always going to find out that, okay, as we get more and more data, there's something, big that's kind of running through the data, maybe on 20 or 40-year timeframes, that has some influence. But the scale of the increase in temperatures that we've seen, I mean, we can pin, depending on which climate simulations you use, 80 to 90% of that change is likely just from greenhouse gas concentrations. So that's the best answer I could give you. It's a good question. And with that, I've been talking for 80 minutes straight. So thanks everybody.
Well, Ken, this has been absolutely fascinating. Thanks for the talk. And I think you can tell by the number of people we had tuning in and by the questions. It's a really engaging issue, and people are really interested in it. Thanks.